Hey guys, my name is Harsh and today I'll be explaining you why you should never use public Wi-Fi. It could be your college Wi-Fi or Wi-Fi at the airports or other stores that you get for free through a basic demonstration of a man-in-the-middle attack, specifically ARP poisoning. So it's not as complicated as it sounds. It's a very basic implementation. To get a better understanding of what's going on, let's consider an example of a home network which consists of a router, a PC and a mobile phone. So imagine a case where I want to watch a YouTube video on my phone. I need the video from the YouTube server, so I ask the router to get it for me. The router will send the request to the server will send it back to the router, and the router will send it to my phone. Now this communication takes place only between the router and my phone and not with my PC, which is also on the network. How does my phone know whom to send the request, and how does my router know who is sending my requests and where to send the data or the necessary information that it has fetched? So this is done through two types of addresses, IP and MAC. Think of IP address as a name of a person and MAC address as its living address. So if I want to send a package from my router to my phone, I also need the name as well as the address where the phone lies. So what happens in this case is my phone will ask the router to send the YouTube video. The router will go to the server, it will get the video, and then it will send it to my phone. Before we go ahead, I just want to clarify this method of getting the MAC address through the IP address. For example, I want to send something to my router. I just know its IP address, that is 10.0.0.2. Now my mobile phone uses ARP, which is Address Resolution Protocol. What this protocol does is it will get you the MAC address for which the IP address you have provided. So it's like my phone says, hey ARP, I want something from 10.0.0.2, but I cannot find it. So where does this person live? So ARP will give him the address, and now this communication system takes place. And surprisingly, I am a malicious person here. So what I do is I send certain packets to my phone, telling my phone that hey, the MAC address of the router, that is FE81, is not the router, but BF40 is the router. So my phone thinks now that in order to get the information through the internet, I need to ask this person for the information. And now what I do is I tell my router that hey, the SG50 that was my phone is not the phone, but BF40 is the phone. So now the router thinks that I am the phone, so it will send and receive the details through me. And now I am the man in the middle of this home network, where anything sent from and through the mobile phone and the router is sent through me. So you can imagine I can watch everything and anything that this communication system between the router and phone undergoes. What we have done here is also called man in the middle attack, because I have exploited the ARP protocol into making the router and the phone believe that I am the person they are talking to, but actually I am just sitting in between their personal communication. Okay, so now I hope you have a better understanding of what exactly we will be doing today. Just a quick disclaimer before we actually start performing it, that this video is only for educational purposes and you should never try any of these things that we will learn today on a real world scenario, like actually using it on your college network, because you will face serious consequences if caught. So we need a few things before we actually perform the attack. One is that you must be a part of your host network, and you need two types of addresses. One is IP address of your machine through which you will attack, and also the IP address of the target machine. So now I have a Linux virtual box running. I'll just quickly find out what's my IP address. ifconfig. Okay, so as you can see, my IP address is 192.168.1.13, and I'll be performing the attack on my actual Windows machine. Actually, I should have used another virtual box, but it's fine. IP config for Windows. Okay, ipconfig. Okay, so my IP address is 192.168.1.1. Of course, I cannot show you the MAC address and other details. Okay, so now I have the IP address of both my machines. I'll just show you what my network looks like right now. ARP-A. Now ARP-A will give you a list of all the devices that are connected to your network. So you can see this is my IP address, and these are the devices that are connected to the same network. I guess my Linux machine, what's my IP address? 13. Okay, as you can see, it is not visible right now on my Windows machine. Even if I compare the MAC addresses, it's not yet visible. There are also ways to see the devices through Linux as well. One good way is using nmap. So nmaps-sn, this is my range of IP addresses, so it will basically use this subnet, which is 192.168.1.0, and 0 to 24 is the range. That means that it will send network packets to all the combinations from 0 to 255 to see if I get a response back. So let's run it. Okay, so now it's done. As you can see, there are quite a few devices that I also showed you through Windows machine. We are now good to go with the actual attack. So there are a few ways you can do this. One is through bettercap, and another one is through bettercap. I'll use bettercap just because I find it more comfortable, and the UI is also quite readable. So we'll launch bettercap. Okay, it won't launch because it requires root privileges. So if you firstly, if you don't have bettercap, you can install it through sudo apt install bettercap-y. Now I've already installed it, so if you want, you can install it through this command. Now root privileges enable the application to run without any system imposed boundaries. So we'll now start bettercap sudo bettercap and enter my password. Okay, so now bettercap is running. So you can always use help to see what the tool offers. These are the processes that are running. Events.stream runs by default. So now let's do help and then net.probe. If you wish to read in detail about any of these specific processes, you can use this. So netprobe keeps probing for network's host by sending dummy UDP packets to every possible IP on the subnet. So it works basically in the same way like nmap works. We had to provide the subnet, and then we entered the range 0 to 24. So basically it works in a similar way. It will notify you about all the devices that are on your network, and also keep updating you if any device is added or not. So now let's use this command, net dot probe space on. So now you can look at all the devices that are here. There is a better way to look at these, net dot show. Okay, so this table basically again displays all the devices. Intel Corporation, as I showed you earlier, this is the device, my target device of my actual Windows machine, and this is the IP address, ARP.spoo.fullduplex true. Okay, so now full duplex is enabled. Now I'll set the target. So just to tell bettercap, both my target machines, which is the router as well as the Windows machine. So I'll write set arp.spoof.targets 192.168.1.1. This is my gateway, default gateway. So this is the IP address of my router. So it goes here, comma. Now I'll enter IP address of my Windows machine, that is 192.168.1. What was it? It was 11. 1. Now if I write help, you can still see the ARP spoof services off. That is because we have only set the targets as of now and the service has not begun. So now let's start ARP.spoof is on. Let me show you, it's running. Okay, now I'll show you the attack has actually worked. Sorry, it's show. Okay, so check out the MAC address of my Linux machine. It ends with 79. And now if I show you r-a, okay, so now my default gateway for the Windows device is also ending with 79. That means our attack is successful. The forwarding is proceeding through my Linux machine to the router, and the router to my Linux machine, and then the Windows machine. To actually see the network traffic, let's go help. Okay, so print the sniffer session configuration. Basically it's just printing the traffic that is going through the Linux machine. So net.sniff on net. Okay, it worked. Alright, so this is the traffic as of now. Let me search something. Let's go with unicorn items. It is an HTTP website. Where is it? It's here. I'll actually show you what difference HTTPS makes, which is always recommended. As you can look here, it says not secure. Why is it not secure? If I go to about us, okay, let me log in. It would be nice. Okay, so I have now actually created a fake account. Let me log in and show it to you again. dummy@gmail.com. Now I'll enter the password. Okay, so now I have actually jumped to the main part. It has captured a lot of network traffic. So to show you what happens in HTTP is, it actually captures it in a way that is so nice. You can actually see the host, including some cookies data and also the origin. But the best part is it has also captured the time when I logged in, dummy@gmail.com. Also my password, which is dummy@12345. This is why they say never to use an HTTP website, because you never know who's watching. And now have everything to access your account, but if you compare it to yep, this is an HTTPS traffic. You can obviously see there are a very few details that are shown here. Another way to protect yourself is if you are actually using public Wi-Fi is to use a VPN. It could even reduce the amount of data that is shown here for HTTPS traffic. I mean, for Amazon, I have received this much of data, but if I had used VPN, it would be probably even less, and I wouldn't even know it was Amazon.in. It actually could hide the domain names as well. So these are some ways that you could use to protect yourself. So that is pretty much it for this video. If you have learned something new, let me know in the comments what would you like to see next, and if you enjoyed it, please hit the like button. That's it.